Hello, my name is Todd Lyle and I'm a civil engineering student from the Rockhampton campus. Today I'll be giving you a brief rundown of the concepts of stress and strain. Focusing first on stress, it can be defined as the application of a force to any face, internal or external, of an object, and is expressed as force per unit area. For example, if you take a piece of string between 2 points and draw it taut, then you are applying a force relative to the cross-sectional face of the string. This force can be said to be causing stress in the string, which logically, when the stress reaches a certain point, will cause the string to snap or fail. This particular example is of a tensile force. Similar to a tensile stress, compressive stress is where the force is applied normal to the face of an object, inwards so as to compress the object. This could be explained by a concrete column which is supporting a balcony. The balcony is applying a force relative to its weight, while at the bottom of the column there is a normal force opposite to the weight. This will tend to compress the column. The third main type of stress is shear stress, which is where the force is applied perpendicular to the face of the object. To explain this, imagine the glue in the image is replaced by a bolt through the two objects. To separate them, the bolt would be broken in half at the point where the two objects meet, or more correctly, sheared in half. So now that we have established a basic understanding of stress, we can look at how and why it is important. Most simply, it can be used to gain a quantitative understanding of when and how an object will fail. In the three images, we can see that each of them have failed in a different way. The tensile force in the chain has caused the link to break. The compressive force perpendicular to the internal face of the concrete beam has caused it to shear, and the compressive force on the cylinder has caused it to explode. By understanding how the forces we apply to objects will cause them to fail, we can understand how we can counter them. Taking the concrete beam from before as an example, this image shows the expected failure modes for this beam, as we understand how the beam will fail due to the stresses it is under. As seen below, we can reinforce the beam with metal rebar to give it support against the different expected failure modes. Vertical reinforcement will prevent shearing, while horizontal reinforcement will prevent compressive and tensile failure. This is just one example of how understanding of stress can be used. Moving on, strain is the resultant deformation of an object due to stress. This is commonly seen, for example, when a beam fails and it flexes before this. There are two main phases of strain, which are elastic and plastic deformation. Within the elastic phase, the object is free to return to its original shape. Plastic deformation is when the object passes its yield point and begins to move into the strain hardening and necking phase. At this point, the object begins to deform rapidly relative to the stress it's experiencing, until it eventually breaks. This can be seen in the stress-strain graph, which shows the relationship between the two. An important feature of the graph is its definition of the elastic gradient as Young's modulus. This modulus is the ratio of stress and strain, which is essential to successfully model the behavior of the system under stress. In the table, we can see the modulus of a variety of different materials. To summarize, here is a short clip featuring the topics we have covered today. A copper rod is subjected to a tensile force, and we can see that it moves through the different phases of strain, showing noticeable necking before it fails. I hope that I have provided you with an opportunity to learn something new, and would welcome your feedback in the comments below. Thank you for watching.